The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually, we're going to go on to section 6.4. But before we do that, we've got some questions. This is from 6.3, part 1. And this is number 19. It says, factor the polynomial completely. If the expression is not factorable using integers, enter prime. All right, it says 6s to the 5th power minus 26s to the 4th power minus 20s to the 3rd power. So this is a trinomial. It's in standard form. There's a greatest common factor, which would be 2s cubed. So taking that out, we have 3s squared minus 13s minus 10 left over. Now, here we have a trinomial that does not have a leading coefficient of a 1. So now this was from section 6.3 part 1. So this is where we're still using the grouping method. So I'm going to do that here. A is 3, B is negative 13, C is negative 10, the product is negative 30, the sum is negative 13. How about negative 15 and 2? That would give you a product of negative 30 and a sum of negative 13. So we get 2s cubed, 3s squared minus 15s plus 2s minus 10, using factoring by grouping. Let's see here. The greatest common factor of the first two terms would be 3s. We'd have s minus 5 left over, s minus 5 left over, plus 2 outside. So we get 2s cubed times s minus 5 times 3s plus 2. Any questions about that example? All right, and we'll go on to problem number 22 in that section. Factor the following by choosing the correct method. X cubed minus x squared plus 9x minus 9. Typically, when we have 4 terms, it isn't always, but quite often it's factoring by grouping, which is what we're going to do here. There's no greatest common factor to all 4 terms, so we'll just start out by doing the factoring by grouping. The greatest common factor of the first 2 terms is x squared. The leftovers are x minus 1. So for the second group, the leftovers are x minus 1, and we'll take out a plus 9, which gives us x minus 1 times the quantity x squared plus 9. Okay, and finally, number 25, which again says factor by choosing the correct method. And we have 49 into the 8th minus 97 into the 7th minus 2 into the 6th. Let's see, the greatest common factor here is in to the 6th. We have 49 in squared minus 97 in minus 2 left over. So A is 49, B is negative 97, and C is negative 2. The product is negative 98. The sum is negative 97. The two numbers are negative 98 and 1. Their product is negative 98. Their sum is negative 97. So we've got into the 6th times 49 n squared minus 98 n plus n minus 2. Factoring by grouping, we get into the 6th, greatest common factor of the first 2 terms, 49n leftovers n minus 2, leftovers n minus 2, outside of plus 1, into the 6th, n minus 2, 49n plus 49n plus 1. And there we have it. Any questions about that one? Any other questions from any of you that you want to look at before we go on? Okay, then we shall go on to the next section, which is 6.4. Okay, so we're going to look at a couple of new things today. First of them, the first one of them is something called a perfect square. Now, a perfect square is a number slow down, that has two identical factors. So for instance, x squared plus 6x plus 9 is x plus 3 times x plus 3, or x plus 3, the quantity squared. So because this trinomial has two identical factors, it is called a perfect square trinomial. Now, with a perfect square trinomial, there is a pattern that we can look for, okay? If a polynomial is a perfect square, trinomial that is a perfect square, the first term is always a perfect square. The last term is always a perfect square, and there has to be a plus sign in front of the last term. Now, there are some other characteristics, but I choose not to go there. I think that this is enough to get by with. So if I've got a polynomial that I think might be a perfect square, rather than using the previous methods of factoring, I will look to see, is it a perfect square? Because if it is, that's easier to factor. Now, for instance, consider this: 9y squared minus 30y plus 25. This is a trinomial in standard form with no greatest common factor. So now, before I go through that whole grouping ABCPS stuff, could this be a perfect square? Does it have the necessary pieces? Well, it starts with a square, it ends with a square, and there's a plus sign there. So it has all of those characteristics. Now, this doesn't guarantee it's a perfect square, but if these three things aren't present, it's definitely not a perfect square. So let's see if it is. Well, if it is, the 9y squared would have to be broken apart 3y and 3y. The 25 would have to be broken apart 5 and 5. But the middle term is negative, so it would have to be a -5 and a -5. Does this give me 9y squared? Yes. Plus 25? Yes. Does it give me minus 30y in the middle? Yes, it does, because here's minus 15y and there's minus 15y. So yes, it's a perfect square trinomial, and we can write the factors like that, or we can write them like this. Okay? Any questions about that? All right, let's take a look at another example. Y squared plus 4y plus 16. This is a trinomial in standard form with no greatest common factor, okay? It starts with a square, it ends with a square, and has a plus sign in front of the last term. So it could be a perfect square. The y squared would get broken apart. The 16 would get broken apart. It'd have to be a plus and a plus. Oh, but that gives us 8y in the middle, doesn't it? So no, this is not a perfect square. So then I would go on and try other methods of trying to factor it. It has a leading coefficient of a 1, so that would take us back to section 6.2, etc. Not going to worry about that right now, mostly just focusing on, is it a perfect square? Okay. How about this one? M squared plus 12m plus 36. This is a trinomial in standard form. No greatest common factor. It starts with a square and ends with a square, and there's a plus sign in front of it. So it's a good candidate. Let's see if it is. We break apart the m squared and the 36. It's got to be what? Plus. Does that give me plus 12m in the middle? Yes, it does. So there's the answer. Or again, I could write it that way as well. But can you see how that if it's a perfect square, factoring it is faster doing it that way than trying the other methods? Okay. How about this one? 121 plus 4x squared plus 44x. Well, this is not in standard form. So the first thing we're going to do is put it in standard form. Okay. It starts with a square, it ends with a square, and there's a plus sign in front. So this would be what? 2x, 11, 11. Because 11 times 11 is 121. It's got to be a plus, so plus and plus. Does that give me plus 44x in the middle? Yes, it does. Plus 22x, plus 22x. So there's the answer, or we could write it like that. How about this one? 25a squared plus 30ab plus 9b squared. This is a trinomial. It's in standard form. There's no greatest common factor. It starts with a square and ends with a square and a plus sign in front. So let's see if it is. It would be 5a, 5a, 3b, 3b. It would have to be plus. Does that give me plus 15ab in the middle? Yes, it does. So there's the answer. Or you could write it that way as well. Okay, any questions so far?
Where did you get the 15 again? From the 5 and the...
From 5 times 3?
Yeah, I don't know where the, why we're looking for 15 again. I got lost.
Okay, let's go back and slow down. All right, so if it's a perfect square, it would have to start with a perfect square and end with a perfect square and have a plus sign in front of the last term. If it meets all of those conditions, then it might be a perfect square. So it might be, so now I'm going to verify whether it is or not. I'm going to take the 25a squared and split it apart, 5a and 5a. Okay.
Okay.
I'm going to take the 9b squared and split it apart, 3b and 3b. So basically, I'm taking the square root, but I have to have a plus 30ab in the middle. So these would both have to be a plus sign. Now, there's my 25a squared. There's my 9b squared. But where do I get this from? I get it from this and this. This would be 5a times 3b is 15ab. 3b times 5a is 15ab. 15ab plus 15ab.
Oh, okay.
All righty.
Okay, thank you.
You bet. And then again, you could also write it like that. Okay, we're going to put that aside now and look at another possibility. And this has to do with something called the difference of two squares. Going back to chapter 5 briefly, when we're foiling together two binomials that are called a conjugate pair, that means you have the sum of two numbers times the difference of the same two numbers. So we've got x plus 3, x minus 3. This is a conjugate pair. When you FOIL or multiply those together, what happens? The middle two terms cancel out and we get a binomial answer. This is called the difference of two squares, because we have the difference of two squares. Okay, x squared is a square, 9 is a square, 3 squared, and a subtraction, so it's a difference of two squares. So when we multiply together a conjugate pair, the result is the difference of two squares. Now, why is that important to us factoring? Because if we're going to go the other way, if we have a binomial, okay, we've been looking at trinomials, but if we have a binomial that can be written as the difference of two squares, the factors are the sum of the bases times the difference of the bases. Okay, so again, this is not a trinomial, it's a binomial. Now, if it can be written in this form, then there's the factors. Now, this is not considered factoring it. This is just testing it to verify whether it is or is not the difference of two squares. But it also tells me what my sum and difference bases are going to be. Okay, so starting over with that idea, let's say we've got x squared minus 25. This is a binomial. It has a subtraction sign in the middle. X squared is x squared. 25 is 5 squared. So my bases are the x and the 5. So I've got factors of the sum of the bases times the difference of the bases. Now, don't confuse this with a perfect square. A perfect square trinomial, 3 terms, has 2 identical factors. The difference of two squares has 2 factors that are a conjugate pair, the sum of 2 numbers times the difference of 2 numbers, the 2 numbers being the bases from there. Okay, how about this one? 49 minus w squared. So that would be, let's see, 7 squared minus w squared. So 7 plus w. 7 minus w. You see that? Okay. How about h squared minus 144? Well, that would be h squared minus 12 squared. So it'd be h plus 12 times h minus 12. Any questions so far? All right. And if I'm going too fast, let me know. I can slow down.
How would you prefer us to how would you prefer us to write it on test?
What do you mean? How would I prefer?
So for the final answer is just the parentheses h plus 12 and then h minus 12, okay? Or do you want the h squared minus
Oh,
12
this
squared?
this is not part of the answer. This is just verifying that yes, it's the difference of two squares. So this is what you would write. Okay.
Okay, that had me really confused.
Okay. In fact, let's go back to the previous stuff. Okay. It's like looking at this and seeing that that's a square and that's a square and that's a plus sign there. That's looking at it and saying, oh, it could be a perfect square. Okay. Here, this is saying, oh, it's the difference of two squares. Now let's factor it. Oh, it's the difference of two squares. Now let's factor it. So this isn't the factoring. This is verifying it's the difference of two squares. Okay. For example, let's take a look at this one. Is this the difference of two squares? Let's see, 11a and b. What's wrong with it?
They have different, I don't know, I forgot the correct term, but it's a squared and b squared. or the plus, never mind.
It's not the difference because it's plus. It's the sum of two squares, but the sum of two squares, the sum of two squares is not what we're looking for. We're looking for the difference of two squares. Okay. Now, this one is prime. Does that mean that the sum of two squares doesn't factor? Well, be careful. Let's take a look at this. This is the sum of two squares. It's 2x, the quantity squared, plus 4, the quantity squared. So it's the sum of two squares. Can I factor it? Yes, because I can take out a greatest common factor. But once I've taken out any greatest common factor, the sum of two squares does not factor. Okay? So does the sum of two squares factor? Well, that depends. Have you taken out any greatest common factor? If you've done that first, then what's left doesn't factor any further. But let's say I just had this problem to start with. That would be prime. Okay. What about this one? X squared minus 27. (27) isn't a square, so it's not the difference of two squares. Okay. And we're talking squares of integers, because there isn't an integer whose square is 27. Okay. We okay to keep going? All right, what about this one? 49d squared minus 16. Is there a greatest common factor? No. Is what's left over the difference of two squares? 7d, 4. 7d plus 4, 7d minus 4. Now, people sometimes say, why do I bother doing this? Okay. And the reason I bother doing that is to force you to think about what are these numbers, because what I'll get is I'll get students that will do this. They'll go, oh, let's see, that's 7d plus 16, 7d minus 16. Or they'll go 49, oops, 49d plus 4, 49d minus 4. They won't think about that both of these have to be written as a square, not just the d squared, but the 49. So it's got to be 7d squared minus 4 squared. And then you get come on, what's going on here? So then you get the 7d plus 4, 7d minus 4. So again, I do this to force you to stop and think about what are the bases. It's not 49d, it's 7d. That whole 7d, that's what's being squared. 4, that's what's being squared. Okay. How about this? Let's see here. 400 z squared minus 1. This is a binomial. It's got a subtraction sign in the middle. Can I write it as the difference of two squares? Yeah, don't forget 1 squared is still 1. 20z times 20z is 400z squared. 1 times 1 is 1. So my two factors are 20z plus 1 times 20z minus 1. We okay with that? Any questions there? All right. 4x squared minus z to the 4th. Well, let's see. That would be 2x, quantity squared, and z squared, the quantity squared. So my factors are 2x plus z squared, 2x minus z squared. If you're sitting there going, this seems a lot easier than the stuff we've been doing, it should be. Easy water ball. Okay. How about this one? Negative 121 b to the fourth plus 36a squared. Okay. There's a couple of different ways we can approach this. We could rewrite it so that it's the difference rather than the sum of a negative number and a positive number. Okay. So now I've got what? 6a 11b squared. So I get 6a plus 11b squared times 6a minus 11b squared. Okay. Or I could take the original problem and I could factor out a negative, making it positive 121b to the fourth minus 36a squared. And then I'd have what? 11b squared minus 6a squared, and I have 11b squared plus 6a, 11b squared minus 6a. And these two answers are equivalent. Don't forget that negative sign, it's part of the final answer. So if you're dealing with a binomial and you want to know if it's the difference of two squares, well, it's got to be written as a difference. So either by commuting the terms or by factoring out a negative. But these are both correct answers. Any questions there? Okay. How about this one? Is that the difference of two squares? Anybody?
Yes.
What was that? Yes or no?
Yes, I think.
The correct answer would be yes, but not yet. What do I need to do first? Take out the,
GCF.
there you go. Yeah, so in its current form, it's not the difference of two squares, but you always want to look for a greatest common factor first before you consider what's left, okay? We all right there?
Yeah.
How about this one? 2a squared minus 200b squared. Is this the difference of two squares? Not yet, but after we take out the greatest common factor, then it is, okay? There's an order of doing things. Taking out the greatest common factor is near the top of that order. Okay. Has anybody ever seen a show called Lamb Chops? It was about a lady named Sherry, and she had this puppet that was a lamb. It's like an old show. Has anybody ever seen it? Anybody? The theme song, what's that?
No, I haven't seen
Okay.
it.
The theme song was called The Song That Never Ends. This is the song that never ends, and it goes on and on. Anybody ever hear that?
Yes.
Yeah,
I
I've heard
have.
Yes.
that one.
So you recognize it. Okay.
My siblings sing that a lot.
There you go. That's the theme song from Lamb Chops, I do believe. Now, what does that have to do with anything? Well, this is the polynomial that seems to never end. And let's consider what's going on here. I have the difference of two squares. Y to the fourth is y squared squared. 625 is 25 times 25. So based on that, I could write the following. Oops. But guess what? We aren't through, because this is also the difference of two squares. Y squared minus 5 squared. Now this, the sum of two squares, doesn't factor any further, but this is the song that just never ends. Well, it finally ended there. So there's the final answer. So you get to this point and, oh, you can factor that even further. It ain't over till it's over. We okay with that one? Any questions there? All right, how about this one? Well, I could write that as x squared squared and 1 squared, and I'd get x squared plus 1, x squared minus 1. Well, I can't factor x squared plus 1 any further, but x squared minus 1 is x squared minus 1 squared. So that's x plus 1, x minus 1. So again, that's one of those that factors even further. Okay, let's see here. Any questions? How about this one? Z squared minus 64. Is that factorable? Is it the difference of two squares? Z squared minus 8 squared, so Z plus 8, Z minus 8. Are we through? Yep. How about this one? 25 plus B squared. Is that the difference of two squares?
No.
Is it the sum of two squares?
Yes.
Good. Is there a greatest common factor we can take out?
Yes.
Hmm.
No.
No. So is it factorable?
No.
So what is it? There you go. Okay. Let's see here. How about that? Can you factor that? It's prime. There's no greatest common factor. You can't write it as a difference. It's the sum of two squares, but it doesn't factor. The only thing we could do is take out a greatest common factor if there was one, but there isn't one. Okay, now let's mix them all up. Let's take a look at this problem. This is a trinomial. It's in standard form. There's no greatest common factor. And it has a leading coefficient of a 1, and it's not a perfect square. X squared is a perfect square, but 42 is not. It's got a minus sign in front of it anyway. So we're back in section 6.2. Where we split up the leading term x and x. Product is negative 42. Sum is the positive 1 coefficient of x. Remember this? This was like about 3 days ago. So my product is negative. My sum is positive. How about negative 6 and positive 7? Would that do it?
Yes.
And those numbers go right into the problem. One of the reasons some of my colleagues don't like the grouping method is because students will take a problem like this and they'll use grouping on it, and it's a waste of time. I mean, you don't need to do all that. The leading coefficient is a 1. You just need to find the numbers and plug them in. Okay. When this is not a 1, that's where you use the whole grouping thing. All right. How about this problem? Rx minus Sx plus R minus S. How many terms are there?
Four.
4. What do you typically do when there's 4 terms? What have we been doing with 4 terms?
Grouping.
Exactly. Is there a greatest common factor of all 4 terms? No. So let's group it. Greatest common factor of the first 2 terms is X. Leftovers are R minus S. So the leftovers are R minus S. We need a +1 out front. So we've got R minus S times X plus 1. So that was grouping. What's that? Oh, well, okay. How about this one? X squared minus 9. What are you going to do with that?
The method that we've been doing.
Yeah, that's the difference of 2 squares. So X plus 3, X minus 3. Okay. How about this one? 2y squared minus 128z squared. Well, that's a difference. It's a binomial. Is it the difference of 2 squares?
Not yet.
Good answer. Not yet. We'll take out the greatest common factor. Now, we've got 2 times y plus 8z times y minus 8z. Excellent. How about this one? 4b squared minus 20b plus 25. This isn't a binomial, so it's not the difference of 2 squares. It's a trinomial. It's in standard form. It has no greatest common factor. The leading coefficient is not a 1. Oh, but the leading coefficient is a square, isn't it? 4b squared would be 2b, the quantity squared. And 25 is a square, and there's a plus sign in front of it. So, oh, but the middle term's negative, so we'd have to have 2 negatives. Does that give me minus 20b in the middle? Sure does. So it's that, or you could write it like this. Don't make this mistake. Don't take an answer that's the difference of 2 squares and write it like that or like that. You can't, because these 2 terms or these 2 factors are not identical. So you can't do that. It's only when it's a perfect square, identical factors. All right. Okay, so that's it for today. I will be back at 1:15 this afternoon. Should you have any questions? Otherwise, have a glorious, safe weekend. And hopefully we won't get a whole bunch more snow. I'm going to stop the recording.